Afternoon, everyone. Thanks for joining us. A couple more sessions to go before the end of the day, so thanks for sticking with it. Next on the agenda is Tim from Cisco. He's going to talk about being a purple penguin. So, welcome to the stage.
Good afternoon, everybody. It's a little bit quiet, but thank you for bearing with me. So, hands up here who uses MITRE ATT&CK as part of their job. Okay, right, so this is a talk for you. This is about how to give back to MITRE and give back to the attack framework. So I'm a purple penguin. Why the title? So a little bit of background about me. So I am Tim. I own an ISP. I used to work in financial services. I've done pretty much every part of the security lifecycle. I've pen tested. I've delivered SOC capability. I've done incident response. But most recently during COVID, I was kind of looking at MITRE ATT&CK and going, well, my background is Linux security. How can we make the coverage better? How can we improve it? And I ranted about this at an attack event, and MITRE came back and said, how would you like to fix it? So previously, just by way of a little bit of background, setting the scene, you can see on the right-hand side, I've done a fair amount of offensive security, and left-hand side more recently, looking at how do we improve our coverage, how do we improve our detections, how do we make better use of the intelligence that's available. So all of this is about bringing my offensive side to MITRE ATT&CK. As I said, I've been in this industry for far too long. I am one of those aforementioned old white guys. But I would like to improve things. I would like to share back to the community, and MITRE seemed key. So the framework itself has been a phenomenal success, so much so that MITRE will tell you they're thinking about spinning out as a separate entity. They're concerned at this stage that it needs to live on whether they have the funding to support it or not. But from a community perspective, it's helped all of us, whether we're IR people trying to work out what's happened on our networks, whether we're red teamers trying to work out what we should be simulating and why, where we're threat intelligence people who are just looking for that narrative, that story that allows them to explain to the business what they should be worried about. And that's no less true than for myself. I've written tens of projects. There are 3 up there, but yeah, I could have listed another 100 of ideas that I've had, madcap though they may be. Linux-malware is probably my most successful project, but in the grand scheme, all of that only happens because people contribute back, and there are lots of places that we could be contributing back, and here's a few ideas on where. How do we improve the detection capabilities of our organisations? How do we improve the detection capabilities of our countries? How do we make sure we're testing the right things for our customers? Those questions become a lot more interesting if you've got a real fascination with one particular area. For me, it's Linux. The threat landscape has changed massively. You look at days gone by, the North Koreans were probably about the only people that were really kicking the big-end systems, the big-end databases that made our world work, that made our communities flourish and survive. But more recently, we've seen an uptick in what threat actors are doing and why. The middle one, Cisco tools, I'm going to call that out very specifically. We've written lots of tools. I kind of was quite interested to see how long it would take to detect our tools in use with threat actors, and it happened around the 13th of May 2022. But anyway, yeah, the threat surface, the threat landscape is changing. This is broadly what it looks like today. Botnets and Bitcoins, IoT at the top. Access brokers, we're all familiar with the idea of people getting into your network and deploying ransomware, for example. And there are people that are quite interested in cloud security, you know, the idea that your AWS tenancy, your GCP tenancy, etc., they might target that because they want the compute, because they want the data, etc. But where I'm really interested is those specialists, those people that are going after very specific things with very particular niche targets in mind. Niche targets in mind, but they're probably the things you've got in your pocket. Your payment systems that allow you to make and buy goods and services. The telecom systems that allow you to, for example, make and receive a phone call. Ensure that the text message gets to your mum on time, etc. So Linux-malware was an attempt to try and classify some of that and to take what good threat intelligence exists out there, and there is some, and do more with it. Because I think one of the things from a Unix natives perspective that I've spotted over the years is threat intelligence doesn't always tell the whole story, not because it's not reported, but because people don't know what to pick up on, why to interpret it, how to act on the back of it. So Linux-malware is my attempt to work with MITRE to build out a better narrative around how people get into the systems that I've just described as being really important, your SS7 gateway, your system of record in the bank, etc. So there you go, that's the background. My big mouth in May 2020, when I talked around threat intelligence, threat hunting, threat simulation, how that could work. I actually gave this talk, I think, at one of the CRESTCons. I've spoken on the red teaming track, the IR track, and the threat intelligence track at various different junctures. But I think that first talk actually also came out of CREST. But anyway, yeah, over time, things have adapted, things have changed, and I've been trying to push forwards the telemetry and the understanding of attacks along that timeline. 2021, that's kind of when MITRE turned around and said to me, well, we saw your talk, how can you help us fix things? And then moving on from there, iteratively making things better. So, this is where it all started. I said I'm interested in the really interesting systems that keep our economy afloat, that keep our CNI safe. I built some honeypots and put them on the internet. I was kind of curious, if I put big systems on the internet that would be valuable, will anyone find them? Some people found instance 2. That's fairly generic, but they didn't really find a huge amount with instance type 1. And I was like, well, okay, it's on the internet, perhaps that's why it's not been found, etc. But it wasn't enough to give me any useful data to understand how adversaries were working. So we kind of went, okay, that doesn't work, what else can we do? And we went and looked at Malware Bazaar. Malware Bazaar, for those of you that don't know, is a little bit like VirusTotal, but it's free entry point. You can run your own hunts, it's got APIs, you can look at statistics, you can build out Yarrow rules, you can do all of the things that you need to prove a good idea without any of the cost, which makes it fantastic for community audiences in a way that VirusTotal, whilst it's brilliant, perhaps isn't. So yeah, what I really wanted was Unix malware. Specifically, at the time, I was looking at AIX malware, but Unix malware in a general sense. And most of what's in VirusTotal, most of what's in Malware Bazaar is, unfortunately, Common or Garden IAT malware. It's still interesting, but perhaps not that interesting. You know, there's only so many times you can look at a MITRE binary before you kind of scratch your eyes and walk off and do something else. So there you go. That's what Malware Bazaar looks like today, and you can see on the far side MITRE stacks of it, 64-bit, not a huge amount, and so on in between. But yeah, it was a starting point. At least had some data I could use usefully to understand what was being deployed and where and why. So things you can do once you've got some ELF malware, you can scan it with an AV product, you can write Yarrow rules for it, you can run it through Kappa to understand what the behaviour looks like, you can even just strings it and look for interesting bits and pieces. And indeed, you can leverage the tags that already exist inside Malware Bazaar today to start to understand which bits of malware you're interested in. And if you're so inclined, you can go and reverse engineer it and figure out exactly what it's doing and why. And that in itself is kind of quite fun. Malware developers don't exactly follow an SDLC. For those of you that perhaps aren't quite so familiar with Unix shells, that's essentially fetching a piece of malware over an insecure protocol, doing the utmost to make it work, but in a way that actually is probably exploitable if you were the blue team. Kind of thing that's kind of quite interesting to know about. Can you exploit the exploiters? Well, if it's your system, possibly you can do. If it's someone else's system, probably not. But yeah, looking for AIX malware. Didn't find a huge amount. You can see all of the different Yarrow rules I set up. The only one that really got a huge amount of hits was AD on Unix, and that was actually probably more to do with the AD aspect than the Unix aspect. These numbers have gone up in the meantime, and there are starting to see things that are a bit more interesting, but that was kind of 2020 first take on this. And there's one of the reasons why. So if you have a piece of AIX malware and you run it through a destination box, whether that's VirusTotal, whether that's, as in this case, Malware Bazaar, the assumption that it's actually going to do anything useful with it, it's not always true. So essentially, I'd found some samples of the fast cache malware, the North Korean piece that was essentially stealing money off the Swift network. I ran it through Malware Bazaar and it didn't find it. It didn't even recognize it as an AIX binary. So there are always assumptions you have to deal with when you're building out intelligence. The idea that you can just simply take a piece of information verbatim and reuse it isn't always true. So, good news and bad news in 2020. No matches on most of my hunts. Malware Bazaar's not the only place to detonate stuff, so let's have a look at somewhere else. That is a piece of tooling that I wrote with a 1-byte change, and it goes from 31 detections to 7 detections. It's only detecting off the hash, and actually the vendor that is detecting it, of which I think there is currently only one, is still currently trying to get to a point where they can detect it reliably. I've got a friend that keeps on submitting it to them, and every time they write detection for it, he changes a byte and he resubmits it. He works for a SOC. He wants to be able to detect it reliably. He's working directly with that vendor to make sure that when that malware appears on when that offensive tool appears on their network, that he'll see it and he'll know why it's there. But if that's what it looks like in VirusTotal, which is kind of the ground truth and the holy grail of kind of malware and malicious binaries and suspicious binaries, what chance do we have of finding the stuff I really want to find? We don't. That's why I want to improve MITRE ATT&CK. That's why I want to encourage others to communicate with MITRE and talk about the things that interest you, the challenges that you have, so that we build a better, stronger community together. If we all do our individual pieces in isolation, we don't really lift the whole ship. So yeah, does it matter? I've just explained why, but the binaries were for fast cache. Pretty interesting malware. You'd want to know if the North Koreans were stealing money off you, right? But we can't detect that reliably, and it's been reported. What else is there out there? So 3 hypotheses. Attackers are using our tools, and when I say our tools, I mean myself and Pentest Monkey, who's not in the room, but is also another Unix researcher at Cisco. Attackers who are using our techniques, and perhaps the idea that attack doesn't represent what we need it to represent to make it useful. So the first one, tool on the left-hand side, Unix PrivScheck, that was written by myself and Pentest Monkey. Linux was written entirely by me. There you go, those are the things that you should be able to detect on it in terms of techniques that it would trigger on. How many of them will your EDR pick up today? I would posit in most cases none, which is probably a concern. Yeah, somebody gets onto a Linux web server and they start to move across your estate because you've joined your Linux systems to Active Directory, you'd want to know if they're moving across the estate, and we can't. Hypothesis 2. Lazarus Group, Hidden Cobra, they were the fast cache people. Those are the kinds of things that they're doing on your systems if they get access to them. Again, can we detect them reliably? Well, not if it's not a hash match. And thirdly, this is slightly more recent. This is a fantastic piece of work by, I think, Mandiant and CrowdStrike, looking at a threat actor called Lightbasin, or UNC 1945, who are attacking telecoms boxes to essentially retrieve your phone calls, retrieve your text messages, leverage that connectivity to steal the things that matter most to you, your messages to your loved ones, etc. And yeah, Mandiant and CrowdStrike found it in that instance, but that's one hit in my entire life that I can think of. It doesn't happen very often. I'm pretty sure there's more stuff out there. Curiously, one of the tools that this particular threat actor is using is something I remember from 2001 when I was still at university and playing around with hacking Linux, open source and all that. It's 2001 and we've only spotted it just now. How long have they been using it? Where have they been using it? Why have they been using it? Why haven't we spotted it earlier? Again, back to this point. Attack is not representative of the TTPs that are in use, not representative of the TTPs that I use, and it's not representative necessarily of the TTPs that our real adversary would use. So, engineering better threat intelligence. First thing, look at what's already out there. Kappa from Mandiant essentially will take a binary and decompose it, pulls out lots of interesting things, runs forever, and time-consuming and not necessarily as helpful as I would like. It's great if you've got the time, but when you're trying to run thousands of samples through, it's perhaps not the place I would start. So we took a different approach again. We went and took all the threat intelligence that we were seeing from others, all of those reports that get reported each year, and we wrote tooling that would go through it and look for other things that weren't necessarily being reported, or weren't actively being reported, or weren't in attack today. Sometimes it was artifacts that had been misattributed. Sometimes it was just the wording was different from the wording that we would have expected. Sometimes it was simply that it was in an image. So we wrote tooling that basically decomposes all of your threat intelligence from all of your threat intelligence providers and pulled out more intelligence from the threat intelligence you already have. And there you go. Now you start to see some interesting things. Does it use Go? Does it use non-persistent storage? Does it spoof the process tree? Does it fake an exploit? The XZ example from a few months back where someone backdoored the build process, about 4 months prior to that, someone had backdoored the build process on an exploit that they then put on GitHub for all of red teamers out there to go and run on their customer systems. There's lots of techniques that aren't necessarily well covered, and quite a lot of them are in active use by threat actors that we ought to be concerned with. So, where we are today. We're now automating all of this. So the Linux-malware repo is a manual labour of love for me during my evenings, my weekends, and sometimes during my Cisco working day. They do give me some time to work on it. But we're currently working on automating it. So it will soon be possible to feed a new threat intelligence report in and have all of that automatic analysis happen for us that allows us to say, well, actually, it's reported loads of things that we ought to be putting into MITRE ATT&CK, but we just didn't. The bits in blue are the bits that we can probably safely say work as is. The bits in yellow are the pieces that I'm kind of interested in improving with better machine learning, better heuristics, better analytics of one description or another. But the idea is to get to a place where we have an open source repository of Linux threats that's good enough for MITRE to consume into attack and robust enough to deal with me going on holiday. Because when I go on holiday, it all slows down. And if you want to know the latest and greatest threat actors, you don't want to wait until Tim's come back from 3 weeks in Barbados or a field in Worcestershire, as happened last weekend. So yeah, building a better attack. That was 2021, that's today. Specifically, some people collect CVEs. I am now at the point where I'm collecting MITRE ATT&CK techniques. All of those have had my grubby little hands on them, and they've all improved. All of the ones in my backlog, they're the ones we still need to worry about, but we are steadily making progress and picking out those that are highest priority. So, that's how you get better threat intelligence. We're feeding it back into MITRE. We'd encourage all of you to do likewise. But actually, how do you detect it? Because it's no good just knowing that this threat exists. You've got to be able to do something with it. The number of organisations that don't do a good job of monitoring their Linux boxes is frankly astonishing. But pretty much all of them. EDRs are great, but servers, EDRs, it's not necessarily a match made in heaven. eBPF is where the world is going, and it's definitely where I would suggest that people should be looking in the future, not least of which Cisco's made acquisitions in that space. But audit these mainline today, you can go and put it onto systems that you've had around for 5-6 years. You can take all of the stuff that I'm doing with MITRE ATT&CK and have it running on your Linux network in probably a couple of weeks with the right engineering effort. A little bit of a crib sheet. Not everything in Audit D is quite as transparent as we would like. The man pages were written by coders first, and there are definitely things that you will only learn when you start writing rules. Like, for example, the difference between a 32-bit system call and a 64-bit system call, or the fact that file names reference the original location, not the symlink location, or indeed that sometimes you just simply can't get a string out because it's a piece of hexadecimal. But that's a really dirty script. That script is pretty much the same as I wrote for a bank 20 years ago. We didn't use Audit D because Audit D didn't exist. I was doing it on Solaris, AIX, and HPUX in those days, but more or less that says, show me all the world writable files that relate to a particular piece of software. Now build me a set of Audit D rules that will show me when they're accessed. The reason we did it at the bank was because we had a Swift application that had a vulnerability in it. It had world writable files for everything, and the lawyer said that we couldn't get it fixed quickly. So we wrote some audit code that will essentially allow us to see when people access those files and who they were. Was it the application? Was it somebody that had logged in from a support account that hadn't been logged onto the system in the last 15 years? Possibly, possibly not. A very modern piece of malware. So this is BPF Door. This is one of those pieces that's kind of starting to surface. And again, we've built some detections, we've built some concepts in here. We know what it does, we know how it behaves. All of these things now start to tie into what MITRE ATT&CK is talking about in terms of what an adversary might do. There are some interesting bits, particularly the write, the execute, the delete from a temporary storage area, particularly the piece around having a raw socket used for capturing packets, used for crafting packets to build command and control, etc. Putting it all together, that piece of malware uses those techniques. Traffic signaling is new. It wasn't necessarily something that we considered when we started working on attack with MITRE, but it's certainly something that our adversaries are definitely using today. And if you can't detect on it, you're in problems. So some conclusions. I have rattled fairly quickly, I think, probably more quickly than I intended. I will leave you with this particular thought. If I had 5 things I wish we could see on every Linux system that's in production, and every system that's in development, and every system that's in UAT, can you detect when someone logs into your system? Can you detect when someone changes identity? Can you detect when someone brings up a raw socket, either to capture packets or to create a command and control channel? And this is my lasting message. Every single person in this building, whether they're GRC, whether they're red teaming, whether they're incident response and SOC, or whether they are just the CISO, the chief executive, etc., every single one of us uses attack on a daily basis, and we should all be giving back, because it's only by giving back that we'll lift the entire ocean's worth of ships. And if you work for a threat intelligence team, please make it easy for me to consume your threat intelligence. The number of times I end up scraping horrible HTML files to try and get stuff out that should just be simple.